Today, most industries are served by UAV technology in one way or another. I'm at Riegl USA headquarters in Winter Garden, Florida. Today, we're going to be getting together with Tyler and doing some calibration flights with an H6E electric and their Minivux 3 UAV. One of the things that has caused this relationship to grow the way it has over the years is proximity. Not only are they the leader in UAV LiDAR technology, and we are the leader in UAV technology, we have a proximity that makes this relationship advantageous to both of us. It's about a 30-minute drive for me to get from our office to their headquarters in the US. So let's go out to the field and see what Tyler has for us. Okay, so Tyler, for the people that have never done LiDAR before, what are the things that they might have to do differently than a normal flight? Are there any special steps they have to take?
Really just making sure that you have the right GPS, making sure everything's initialized and working the way you're supposed to, right? It's overall not too difficult. Big thing is make sure you have a static from a start. So
What's a static?
So a static is where you're waking that IMU up. You know, you're giving it time to wake up, you're giving that time for that GPS to log. If you just turn a scanner on and go, it's not going to know where it's at, right? And there's two parts to running LiDAR. With these, it's a 2D scanner, right? The LiDAR itself, it's only in 2 dimensions, so we're getting a flat plane here. That third dimension, that height, comes from that IMU.
Okay, so after they take off, are there any other special steps they have to do before they just start the mission?
With this Ponix IMU, so we're actually running a dynamic as well. So what we'll do is we will go up and we'll fly a north-south in an east-west direction. That way we're getting all 4 headings, so when you're actually flying, your GPS is really calibrated into where it should be.
Okay, so now that we're actually in the mission, I got a couple more questions because people want to get into LiDAR. They don't necessarily know where the advantages are versus normal guys going out with sticks and measuring.
Yeah.
So for example, the property that we're doing here, what kind of resolution do you think you're going to be able to get?
You know, with this Minivux 3, we're looking at a 10 millimeter precision at 50 meters, right? So we're looking at millimeters precision on this stuff.
Oh, for the whole property. Now, if you were to guess, and I know you're not a terrestrial guy, but how long do you think it would take to survey this with guys on the ground?
On the ground, property this size, I mean, you'd probably be looking a week to come out here and stake out everything. You could really push it maybe to a couple days, but you might not get the accuracy you're looking for. The real advantage with this is, while it might not be as accurate as just one point, you're getting millions of points, hundreds of thousands of points a second on this property, and you're able to get through trees a lot better, right? You're having to not send guys out in the field as long. You can have them sit here, fly 10 minutes, and you have everything you need.
Setup for this, somebody'd have to come out here and set up ground control points, which you guys obviously have already.
Yeah.
Ground control points would take, on a property this size, 2 guys, an hour to set them up?
Maybe a little longer, but yeah, it
Okay.
just depends how many you're using. But
Right.
still, you're doing a couple ground control points versus, having a guy come in here, stand.
So our total investment, I mean, we're looking at a 20-minute flight, let's say 4 hours of setup ahead of time, this is still a in the morning before lunch kind of operation as opposed to weeks.
Exactly.